Given that x is a real number, solve the inequality negative 7 is less than 3x plus 5 is less than 7. We are required to solve an inequality, and the principles that we will apply are identical to the principles that we generally apply in the solution of any equation and also in the transposition of formulae. Our proposed subject is x, which of course is our unknown. And like in any circumstance that is similar, our responsibility is to eliminate all those that are accompanying x on the same side. It so happens that in this particular case, x is not taking sides, but x is in its particular section and accompanied by 3 and 5. And of course we have the two extremes where we find negative 7 and 7. So our duty is to eliminate that 3 and that 5. By so doing, we will be solving the inequality for x. There is our inequality. In solving this inequality for x, we need to eliminate those who are accompanying x, which are 3 and 5. We need to eliminate 3. We need to eliminate 5. We will first eliminate the 5 that is accompanying the x term by addition. As we can see right here, plus 5. 5 is accompanying the x term by addition. We will therefore subtract 5. So here we need to eliminate this 5 by subtracting 5. But we just cannot do that to that section alone. In order to maintain the integrity of the inequality, we need to do the same thing in the other sections in order that the other sections will be affected in the same way. We need to eliminate this 5 by subtraction. So we will do that to all sections. So we'll have negative 7 minus 5 is negative 12. Of course, the 5 will be eliminated from this section, and 7 minus 5 is equal to 2. 3 is accompanying x by multiplication. We will eliminate it by division. So we need to eliminate this 3 also. And because it is accompanying x by multiplication, we will eliminate it by division. We will therefore divide 3x by 3. And to maintain the integrity of the inequality, we will do the same to the other sections in order that the other section will be affected in the same way. Divide by 3 in order, that's what we are trying to achieve here. We need to eliminate this 3 that is being multiplied right here. We'll do the opposite of multiplication, which is division. Additionally, we need to maintain the integrity of the inequality, and we will therefore divide the other sections by 3 also. So there we have 3 eliminated, and the x is all by itself. And of course it is not going to be difficult to see that negative 12 divided by 3 is equal to negative 4, and then we will have 2/3 right there. The inequality is solved, and the solution is negative 4 is less than x is less than 2/3. In solving this inequality, we need not go into the finer details of the significance of these inequality signs. Irrespective of what they are, the process is the same, and it is based on the principle of transposition, which is extended to the solution of equations. And it doesn't matter that we do not have an equation with just 2 sides, or even an inequality with just 2 sides. The treatment is the same. the elimination of those that are accompanying the x, and as a matter of fact, treating the other sections in the same way, in such a way that they might be affected in the same way. There is the solution of the inequality. We have that as we read it as negative 4 is less than x is less than 2/3. What we have there is colloquially called two-sided inequality. It has the variable in the middle and values at both ends. There is a special case in which the numbers have the same size but different signs, as in this case, but the inequality signs are usually identical. So this is a typical inequality, especially at the higher levels of mathematics, and we generally call it colloquially two-sided inequality. And later on, when you advance work in mathematics, you will see the benefits and the uses of two-sided inequalities. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.